Well, good afternoon, everyone, and welcome to Xcel Energy's first 2020 Hosting Capacity Stakeholder Workshop. The topic of today's workshop is hosting capacity process, tools, and methodology. We originally scheduled this workshop for March, but ended up delaying it until now due to the COVID-19 pandemic. This is also the reason we changed it to be virtual participation only. We will be hosting a second stakeholder workshop on June 16th, the subject of which is the technical inputs and assumptions associated with our hosting capacity analysis. If you haven't received an invitation to that workshop yet, please let us know via the Zoom chat function, and be sure to note your email address and we'll get that invitation out to you as soon as possible. I note that today's workshop is being recorded and we'll make it available on our website after this live session. We'll also be submitting the PowerPoint slides that we used today in a filing to the Minnesota Public Utilities Commission, and we'll email all participants a link to that filing once we make it later this week. Based on the feedback we've received from stakeholders, our goal for today's workshop is to walk you through our process that we use to develop the hosting capacity results and report and how that fits with our overall system planning process, provide a glimpse into the primary systems that we rely on to produce the hosting capacity information, those being Synergy and the EPRI Drive tool specifically. Finally, we'll dive more deeply into the Drive tool and the various Drive hosting capacity analysis methodologies and how they compare to others. Our presenters today include Luther Miller. Luther is a distribution planning engineer with Xcel Energy. He's been heavily involved in our hosting capacity process for the last 3 years and currently leads the hosting capacity model creation and analysis within our distribution planning team. Luther presented an academic paper exploring the effects of smart inverters on hosting capacity analysis to the general meeting of the IEEE Power and Energy Society and received his Bachelor of Science in Electrical Engineering from the University of St. Thomas in St. Paul. Luther worked at Xcel as an intern prior to joining the organization as a full-time electrical engineer about a year ago. We're also honored to have with us today Dr. Matthew Rylander from the Electric Power Research Institute. Dr. Rylander is a technical lead engineer at EPRI and currently manages the Advanced Analytics project set within the Distribution Operations and Planning Program. His current research activities focus on distribution system issues, such as evaluating the impact of emerging distribution resources on the grid. Dr. Rylander pioneered research surrounding hosting capacity analytics and has implemented those analytics within the industry-leading Drive tool used by over 35 utilities worldwide. Before joining EPRI, Matthew received his doctorate from the University of Texas at Austin in 2008 and worked at the Electric Reliability Council of Texas. We also have a couple of other Xcel Energy experts available here today to help with your questions. We have Chris Punt, who currently serves as our manager of DER integration at Xcel Energy. Prior to this role, Chris spent 9 years in distribution system planning and has been involved in and led the hosting capacity process since it started back in 2015, 2016. We also have with us today Mary Santori, who is our manager of distribution system planning for the Xcel Energy North area, which includes Minnesota, Wisconsin, North Dakota, South Dakota, and Michigan. Now for a few logistics. We want this session to be interactive. We want to hear your questions. We want to hear your feedback. That said, we've muted your microphones as we get started here today. So as we get going, please either raise your hand if you want to jump in with a question or comment, or use the chat function to type your question, which we'll be monitoring. Obviously, if you want to jump into the conversation, you're going to need to unmute yourself. So there's a set of tools on the bottom of your Zoom window, and one of those should allow you to unmute your microphone. If you have any problems, send a chat and we'll either answer that question or we'll figure out what's going on technically. We do have a time built in for this to be interactive, but if it feels like we're getting behind schedule and that we might not be able to get through the slides, we may ask you to hold your questions to the end so that we can get through those slides. And then we would ask that with your questions, if you could state your name and the name of the organization you are with or that you're representing, if that's applicable. Now, unless there's any questions right off the bat, I'll turn it over to Luther Miller, our first presenter. He'll take us through the analysis process, and then we've got a break scheduled for 1:30 to 2 p.m. Central. And after that, we'll pick up with Dr. Rylander from EPRI. All right,
Great, thank you,
Luther.
Jody. Sounds good. Thank you again all for coming. My name is Luther Miller, and as Jody mentioned, I've been working as an engineer for Xcel Energy for over a year, with over 3 years of working in academic experience in hosting capacity analysis. As was stated, this portion of the presentation and this portion of the workshop will be a synergy and drive sort of demonstration and walkthrough for the hosting capacity analysis, and we will get right into it. As many of you should be aware, Xcel Energy has been filing hosting capacity reports for the past several years, beginning in December of 2016. We have maintained compliance with PUC orders and have taken action to consistently update our analysis features and accuracy. Again, this portion of the workshop is dedicated to demonstrating the tools used by Xcel Energy in their modeling, creation, and analysis process. I will be covering Xcel's use of Synergy for both hosting capacity and planning use cases, as well as showing stakeholders what both the Synergy and Drive tools look like and how their outputs are displayed. Please note that along with these topics, there are several related topics, such as inputs and setting choices, that I will likely be deferring to a later workshop or session. Again, the second workshop scheduled for June 16th is primarily around the drive setting choices. So any questions related to those that come up may be asked to hold off until the next workshop. Once again, our primary objectives for this portion of the workshop are to provide a practical demonstration of Synergy and our model creation process there, as well as the analysis process and Drive. I'll also be highlighting the additional functionality of the Drive tool with current and future planned uses. First, I'd like to provide a glance at both the distribution planning and hosting capacity process timeline. Currently, the hosting capacity process, specifically the analysis, is covered by our distribution planning department here at Xcel. So these two timelines have to coexist and work together in order for analysis to be feasible. So for those who are unfamiliar, distribution planning begins its process with a load forecast on all feeders, planning for any load additions or subtractions. Planners will then create a risk analysis for all their feeders, inspecting any cases of overloads or need for outage transfers. Based on this risk analysis, planners create mitigations, which are budgeted and reviewed by other engineers and design. And so as you'll see, load forecasting takes us from September through November, risk analysis from December through January, and mitigation planning from February through March. At the same time, hosting capacity will begin with the gathering of input information from the previous year, as well as any forecasts. This again takes directly from the load forecasting process within distribution planning, and we'll use that information for the analysis. In the distribution planning cycle, the mitigation plans are scored based on their cost, and a budget is created to enact those plans. Memos are created to fully kick off any projects, whether they're capacity or otherwise. And then the projects will begin to have work done on them, where planners will be a supporting role in that. In hosting capacity, based on some of these projects, a remodel list is needed. Xcel Energy has taken a stance of fully remodeling all feeders within a 3-year cycle. However, feeders that have had significant capacity upgrades or load additions or additional DER have been selected to be remodeled every year that those conditions occur. So a list is needed to kind of summarize all of those remodels that are needed. From there, starting in June, the full model creation and analysis portion begins, whether we are creating new models entirely from scratch or reusing our old models, which don't have any significant changes on them. Once the model creation process is complete, the models are then sent through the drive analysis. At this point, once the analysis is complete, the final PUC report and filing is created, as well as the hosting capacity map. I'll open the floor to any questions up to this point. All right, thank you. Moving on. I would like to also provide a history of drive usage and Xcel Energy's hosting capacity analysis. We began in 2015 with Xcel Energy working with EPRI to acquire the drive tool for analysis. This stage of the drive's creation was still fairly young at this point, and Xcel Energy's early adoption allowed us to have significant input as the tool began to evolve. Xcel filed its first hosting capacity analysis in 2016, where in 2017, Drive added the large centralized analysis methodology, and based on stakeholder feedback, Xcel chose to adopt this. The first hosting capacity heat map was also developed and implemented in 2017. 2018 saw the addition of the reverse power flow analysis criteria in Drive, which was immediately adopted. And in 2019, the unintentional islanding analysis criteria was added and again adopted. There were significant updates to Xcel's hosting capacity process, including analysis performed with actual daytime minimum loading and power factor information where available. The hosting capacity map also saw the inclusion of the pop-up functionality. I'd like to provide a brief summary of some of the inputs required for hosting capacity analysis. In our process, a synergy model requires the base GIS feeder model, which is loaded in. The forecasted load is also required with amp balancing and power factor. Next, the secondary and primary customer billing and loading information is required for load allocation. Existing solar garden size and power factor are required as well before the model is ready for analysis. And then during the actual hosting capacity analysis within Drive, daytime minimum load is entered to allow for peak and minimum analysis. I see a question has showed up in chat. Is the map on Xcel's website updated annually or as updates are made on the system? The map is updated annually along with the analysis. So with each iteration of the hosting capacity analysis from Xcel Energy, we update the map. Any other questions?
Hey, Luther, this is Yoki with IREC. Can you hear me?
Yep.
Hey, thanks so much for starting off the presentation here. This is lots of good information. I'm curious, you use forecasted peak load data here, and I'm curious why you're using forecasted rather than historical actuals.
We use forecasted in order to provide a use case for the map. So any developers wishing to interconnect to the use the map as an interconnection tool or reference would be able to see the forecasted loads and any changes that would have on hosting capacity as they lead up to their project in the future. We view that including historical loads would potentially cause confusion, say if a large amount of load was either to be added or taken away. This could cause significant changes in hosting capacity. And I'd reach out to my fellows at Xcel Energy and support there to see if there's any other additional input there.
Yeah, this is Chris Punt. I think Luther said it well. We're trying to capture what's going to be happening on the system. You know, we don't want to have looking back historically, things can change year to year, and we put a lot of time in doing a forecast, and so we think there's good value in using that more forward-looking load forecast as opposed to a historical one that can change year to year.
All right.
So
we
are
also
you
received
looking at a Sorry, quick follow-up question. So is that a forecast for the next year, or are you looking, or is it a forecast for multiple years in the future? What time frame are you looking to afford?
It is a forecast to the next year. All right, we have also received another question from chat asking to remind us from the timeline slide what month of the year the online map is updated. It is updated at the same time of the filing, which is November 1st or thereabouts. So end of October and to November 1st is when the map is updated. Any other follow-up questions? Great, thank you. All right, so moving on. This slide is here to offer a high-level overview, sort of summary of the Synergy model creation process. Again, feeders are either imported directly from our GIS database, or models are reused if no significant capacity projects, load additions, DER additions, et cetera, have occurred. The models imported from GIS require model cleanup in order to be used by Synergy. Feeder accuracy checks and quality assurance is also incorporated in the cleanup step. Next, the forecasted loading and head-end impedance are added to the head portion of the feeder. Several other inputs are entered based on our data, those included, as well as customer loads and metering information. And lastly, solar guard in size and power factor. Once all the inputs have been made into the model and the model is verified as clean and accurate, load is, load is allocated across the feeder. Finally, a load flow is performed to determine voltages and amps across each section. This highlights any potential further areas that need inspection or quality assurance checks. I believe we have a question from Yoki. Are we going to go over the model QA questions I provided in advance later in the presentation, or should I ask those questions now? I believe we will be going over those a little later in the presentation. So please keep them on hold for now. Thank you. All right, so there is quite a lot to unpack in this slide, but I will do my best to provide a high-level summary. This is the main screen of Synergy with two feeder models loaded in. The large black section, map-like section you see here are the feeder models. The various symbols that you see on the feeders indicate equipment such as fuses, switches, capacitors, etc. You can also note that these pieces of equipment are highlighted on this facilities list to the left. From here, we can select any sort of piece of equipment that we wish to inspect further. You can double-click on the piece of equipment and be brought directly to it and edit anything you need there. If we were able to zoom in, we could see that the model is comprised of a large amount of nodes. These nodes are essentially subsections of feeder with a section of conductor in between. Often the overhead nodes are notated by power pole location. though nodes can be somewhat arbitrary in terms of position, but they essentially act as subdivisions between sections of feeders so that different sections can be edited. There are two files that are required for model analysis and synergy. First, there is the actual model file, and then there is the warehouse. The model file contains all the data regarding conductor positioning, type, location, etc., while the warehouse acts as a library to provide any of the needed information for these pieces of equipment. For instance, impedances for conductor types, fuse and capacitor settings, etc. I'd like to note that this model is interactive, with switches, fuses, and other devices able to be opened or closed or have their settings changed during analysis. Planners often use synergy models for contingency analysis, which is again in the case of a feeder fault or other occurrence where load would need to be transferred, or to plan out future extensions or additions of equipment based on projects. They're also able to simulate worst case scenario occurrences. Any questions with the synergy interface page and how it works? This can be a difficult topic to wrap one's head around, so I'm happy to try to provide a deeper dive if needed. Great, thank you. So as stated earlier, the model creation process begins with importing raw GIS data. Xcel Energy has developed an automated cleanup script which performs the majority of the work needed to get the model functioning within Synergy. However, several facilities still require more inspection, such as conductor validation, capacitor bank settings, and step-down transformer configuration. Of these, the conductor verification and validation is the most time-consuming, often requiring check-ins with area engineering, design, and even field verification. On the right side of the slide, we can see an information panel for a piece of conductor, and you can see the various aspects that can be edited. Again, this is one portion of the settings within the conductor. You see there's section information, properties, etc. All can be edited. But on this construction tab, we can see that we can change things like phasing, conductor type, and even the overhead or underground height to reference setting. Yoki, I believe this would be a great time for you to present your questions on verification and cleanup.
Great, thanks. Kind of processing what we're seeing on the screen here as well. So the first question was if there's automatic verification checks for relays, the proper connectivity of laterals, loading and voltage violations, and the size and types of conductors. So I apologize, some of that information's on the screen, but maybe you could just walk through it to help with the explanation.
No worries. So I can speak primarily to loading as well as the conductor validation. Loading we'll be getting into down the road a little bit, but for conductor validation, this requires, again, checking in with our area engineering teams, which have a lot more of a focus on a specific area and group of feeders and substations. This involves checking with our feeder maps and other data to determine whether there are any inaccuracies, or inaccuracies is the incorrect word. If there is any more information to be gleaned from GIS that maybe was loaded in incorrectly, which is unfortunately a case that can happen. Again, all of the cleanup scripts allow the GIS data to be usable within Synergy, but some conductors come in as unknowns, and so the engineers performing the analysis will confirm with our feeder maps, confirm with area engineering, even orchestrate field inspections to see whether the conductors presented in feeder maps or other sources are correct. Does that answer your question?
Yeah, so I guess yeah, I'm curious how much of this is automated and how much of this is
Sure.
manual. I know that once you see there's a problem, it's I guess there are also two aspects to this. I'll break it down even more. What's flagging? You know, what do you have in terms of an automated flag to say, oh, we need to look at this, and to what extent is the process for fixing the problems automated versus manual? So
Sure.
I guess I'm breaking that down into two more questions.
Definitely, no worries. So the process for flagging, especially, I'm going to keep running with the unknown conductor case just because that's, again, a very time-consuming portion. Unknown conductors can be queried and flagged that way. There is a function within Synergy, and I'll be touching on this later, that allows for querying and highlighting of conductors based on a wide variety of conditions, one of which is conductor type. Again, conductors sometimes load in from GIS as unknown. We can query based on the amount of unknown conductors within a model. They'll be highlighted, and we can see those for reference. The actual correction of these unknown conductors and their validation is much more of a manual process. That is when the engineer will need to sit down with a feeder map, as well as take into account the conductors surrounding any unknown conductors, as well as general engineering knowledge. Pardon me. General engineering knowledge, and move forward with any corrections that need to be made.
Hey, Luther, this is Ed.
Thanks. So that
Just to provide a little bit more, and I think to help answer Yoki's question, is that in our cleanup script, when conductors come through as unknown, we directly flag those as unknown. We have created an unknown conductor and made it a very small actual cable. So that way, when you try and run it, but it's listed as overhead, it'll send flags. It's also small enough that it'll, try to impact the actual voltage profile to show low voltage. So it's something that really forces those unknown conductors to be addressed.
Great, thank you. And then are there similar flags for the other, the non-conductor issues that I listed earlier?
So again, during a load flow case, and I'll be discussing that soon, other flags do pop up highlighting any other issues that we're seeing. Usually, so other equipment loads in from GIS primarily with no issues in terms of type. So we're not going to see, a need to change our fuse types frequently. Again, it's just conductors that require that sort of validation. However, their settings may need to be adjusted. A load flow will usually highlight those areas. Often we correct them before even getting to that load flow point in this creation and cleanup section. But if any have slipped past, there's kind of that safety net of a load flow analysis to highlight any other inaccuracies there.
Got it, thank you. And I think my last question on this section is about the problem that Xcel identified in its 2019 HCA about correctly applying excess generation to the feeder. And I was just curious, since this was a problem that you identified in your last report as something that was, that caused an incorrect result in the published results. I'm curious if you have any processes in place to check for that now to make sure that that doesn't happen again.
I'm unfortunately unfamiliar with that report from Bell. I'd reach out to Chris Punt to see if he has any input. Otherwise, I can say that we primarily look for excess generation, again, in the load flow process, those sorts of issues and symptoms caused by excess generation like overvoltage, et cetera. will be raised in the load flow process and that QA check. In terms of full CSG DER for community solar gardens on that larger scale, we manually input that data and ensure that there's no excess generation within those sites. But I'll ask Chris to provide any, or any others from Xcel to provide further answers there.
Yeah, I just add on to that one of the pieces of our validation too is comparing results from past analyses, and that's one of the spots where that gets highlighted. We flag if there's discrepancies between results year to year. If there are, we deep dive into those a little bit more to try to figure out what those issues are. And one of the main issues is new generation being added or excess generation, like we're talking about in this case. And so if we see, hosting capacity diminished by a certain amount on this feeder, we go in and we look at those specific details of those feeders and the amount of DER that was added there to see if that reflects what actually happened and if those results are really what they should be in the end.
Great, thanks, Chris. And is there anything different now than from what you did last year?
So as far as, we haven't run the analysis this year at this point. So we're just getting into the modeling portion here. So we'll be looking at that again, yeah, continuing down that path. And the only thing different maybe could highlight too is just how we get some of that information going forward, how we get the reports on how much is per feeder some of this solar gardens are, that type of a thing. And I'd have to go back. I think you said 2019. I guess I was thinking that was a 2018 issue as well, but maybe I could be wrong on that.
I'm just referencing the 2019 report that was filed with the commission where Xcel identified the problem as producing incorrect results. And if that was referring back to results from 2018, that could be, but I guess I was assuming it was referring to the results from 2019.
Yeah, I think it's from before. I think it was something we corrected, but I'd have to check on that too, for sure.
All right, any other questions on, thank you, Yoji. Any other questions on model creation and cleanup at this point? Great. So the next phase of model creation is inputting loading and head-end impedance information. So once the model has been cleaned up, the load case needs to be added. Head-end impedances are added based on our internal information and are used, or they're a necessity for accurate load flows. The peak forecasted load is entered into the model's head-end as well. Loading information in this case is similar to those peak loads, again, that we report on yearly, potentially what developers will see in KVA or MVA, in pre-application reports, et cetera. It is essentially, in this case, it is a biphase look at the peak conditions seen on the head end of the feeder. And that importance will be touched on in following slides, but it's usually inputted at this point in the process. You can see this top window shows our added head-end impedances and our amp breakdown as well as power factor percentages. Next, customer and DER information is added. Using the customer management module or CMM tool in Synergy, this tool automatically loads in the customer metering and usage data from our server. This data is assigned to model nodes and sections based on secondary transformer location. It's important to note that secondary transformers are not shown within Synergy in our view window, but their nodes and information is still carried out and can be edited with this tool. The data is, yes, primary customer meters may require additional information input such as power factor and other data, while solar garden data, again, a primary interconnection must be inspected manually as power factors are subject to change based on DER conditions. The window on the right here, again, we see the large customer tool, or excuse me, large customer facility within Synergy acts as both a primary customer or primary generator, such as industrial factory or a community solar garden. We can see that this is set up to represent a PV solar garden array with 1 megawatt nameplate value and a -94 lagging power factor. Any questions here? All right, so next is one of the most important steps of the model creation process, which are load allocation and load flow. So as we discussed, the peak load case at the head end of the feeder is entered previously in the model, and now that must be allocated based on the customer metering information and distributed across the entire feeder. So say on one end of the feeder, we have a customer using a lot of load, taking in a lot of energy, while on the other end of the feeder, not so much. There's maybe more residential or smaller farms in a rural setting. Load allocation directs load appropriately to each of those conditions, where branches of feeder that are more lightly loaded will have less allocation, etc. DER is turned off for this load allocation. The peak data that is entered into the feeder is native load, so DER is not involved at that point. So for load allocation, again, it's DER on the primary level. Community solar gardens are turned off. Again, a load flow is a tool used to calculate the amount of amps, volts, and power going into each section of a feeder. Load flows are able to call out exceptions, as we said earlier, and provide quality assurance checks. They will highlight low voltage, overloaded fuses, transformers, or conductors, as well as many other issues that we could see. At this point, DER is then, again, on the primaries, turned back on, and another load flow is performed to ensure that no issues exist with DER acting on a normal case. I will highlight below the output of a load flow. This is just a summary. There is, again, much more to be seen here. But we can see we have 2 feeders, and then this is the summation of the 2. Feeder 1 is experiencing quite a large amount of generation. We have negative kW backflowing into the feeder head with a total kVA of 2.7 MVA. Feeder 2 has about 4.7 MVA of load on it. And again, it's a fully loaded feeder. There's no backfeeding generation here. We can see things like maximum amps, imbalance, connected customer kVA, et cetera. And here on the exception side, we can see the count of exceptions or issues that occur in the model. Usually, again, things like overloaded fuses that could indicate a need for reallocation. These exceptions are fully listed in a separate tab, but just listed as numbers here in the summary. Any additional questions there with load allocation and load flow?
Hey, Luther, Yoki again. Can you go over the loads that are being input there when you're talking about peak load values? Are you talking about system-wide peak load values or feeder level peak load values?
So these are feeder level peak load values for each feeder during the load forecasting process. We evaluate what the current year's peak load was, forecasted beyond, including any load additions or subtractions. And again, so that's fully on the feeder level. And then for each feeder in the analysis, we input that information into the model's head end.
Thanks.
Any other questions there? All right. All right, there are several other functions of Synergy that have quite a bit of use as support within the hosting capacity analysis and planning cycles. So queries, like I discussed earlier, allow sections of feeder to be highlighted.
It's Jody.
Yes.
I see that we got another question about the load allocation, so I just wanted to have
thank
you
you.
pause
Sorry about that.
here and take a look at that.
Absolutely. Thank you. The question is, if there are exceptions even after load allocation when DER are turned off, how are these handled? How does this reflect in the hosting capacity maps? So these exceptions are essentially vetted until they are no longer causing issues before going into analysis. So we essentially will allocate, run a load flow with DER off, look for exceptions in that case, turn the DER back on, perform another load flow, and look for additional exceptions caused by the turned on generation. These exceptions don't necessarily highlight an issue with the overall model. They're often smaller issues that just need to be changed in settings or looked at further, potentially for reallocation if there were any issues there, in order to provide a fully vetted and correct model. Does that help answer your question? All right, I'm assuming so here, nothing. Any other, again, last minute questions with load allocation? Great. So again, we'll discuss some of the additional functions. Like I said, queries are allowing sections of the feeder and conductor to be highlighted based on conductor type, proximity to each other. Queries may be held from, an endpoint of the feeder and run back to the head end of the feeder if any edits are needed there. And essentially, it's a mass editing tool as well as a highlight tool to correct any issues or make any updates. Synergy also has building functionality where sections of conductor may be built out from existing feeder and equipment can be added to these new sections straight from the warehouse. Again, this is less of a tool used in the hosting capacity analysis, but it is very useful in planning when projects are created to add equipment and see its impact on the feeder or extend current service out to interconnect with another feeder or similar things like that. Lastly, there is conditional highlighting, and this is heavily used in the quality assurance portion of the analysis. This highlighting can pinpoint things like loading or conductor type, as well as there's even a highlight for the exceptions from load flows. So again, load flows highlight or load flows calculates the voltage and amps and power going through the sections of feeder. If any issues such as an overloaded fuse pop up, it will again be highlighted with this conditional highlighting. So with that, the Synergy portion of the analysis is complete. The model has been fully vetted and checked for quality assurance and is accurate up to our standards and is now ready to go through the drive analysis. I'm going to stop here again and just offer a point for questions for anything involving the Synergy modeling portion of the analysis. Great. Moving on to the drive full hosting capacity analysis. There are two tools related to drive that Xcel Energy uses, the Model A interface which loads in the synergy model, assigns an off-peak load percentage based on the daytime minimum loading, and converts synergy models to drive input files, which then can be used. Drive then takes these input files, has loaded threshold and analysis settings based on prior setting creations. It performs the analysis, and then further QAing of the hosting capacity analysis and downloading of any summary files or output files can be performed. Again, this is a portion, like Chris mentioned earlier, where there's further QAing, comparing with previous analyses and checking for issues there. This is a window of what the Drive MAI tool looks like. Again, we can see that it's has a chosen directory to the location of our models. Here in step 2, we can see that an off-peak load multiplier is assigned, with peak load being what is currently loaded into the synergy model. Off-peak is reflecting the DML, so say the peak load case is 5 MVA for a feeder with a daytime minimum load of 1 MVA. We could see a peak load multiplier of 1 and an off-peak load multiplier of 0.2 because 1 MVA is 1/5 of 5 MVA. From that point, it's simply MAI runs load flows again and outputs CSV files, which can be used by the Drive tool. The Drive hosting capacity interface looks similar. Again, it is primarily based around settings, which can be loaded and saved as anything is tweaked. Before each hosting capacity analysis, we ensure that any setting updates are complete before the Drive analysis begins, so there is a set amount of settings that are used. I will also like to highlight that not all the settings you see before you must be used with hosting capacity. They are available metrics, but they're not all necessarily applied. The Drive tool has various functions, which again, I'll be getting into. And some of these metrics are aligned with those functions rather than hosting capacity for generation. This screenshot represents some of the settings Xcel has used. This is a question from Yoki. Not necessarily. I believe the screenshot was just taken from the startup from a new version of Drive that I installed on my computer. Settings, again, will be a discussion topic in the second hosting capacity workshop. So kind of fully taking a deeper dive into what settings we choose and why will be discussed then. Any other questions about the Drive or MAI tools? One moment, please. All right. So once the analysis has been performed within Drive, there are several output methods and means to view this data. So first, you'll see the screenshot up here, which is within Drive. This shows a visual representation of a feeder that has been analyzed. We can see that the various criteria can be selected, and their overall feeder statistics can be shown, as well as you can select various points on the feeder, and a little pop-up window will appear showing the most limiting factor. In this case, at this point, I believe right over here, the minimum hosting capacity would be 0.4 megawatts of primary overvoltage, or limited to primary overvoltage. Here we see the actual spreadsheet output of the Drive analysis. We can see in this leftmost column, each of the nodes has been assigned along with their XY coordinates, which are used for mapping. And then associated with each of these nodes is the entirety of all the limiting criteria and values thereof. So we can see that, for instance, for this node, The most limiting criteria would be reverse power flow due to a 0.5 limit, as well as unintentional islanding at that limit as well. Any questions on drive outputs or any further information I should include?
So I think I know the answer to this question, but I'm just going to ask again. This is Yoki. So these drive outputs that we're looking at here with the technical criteria violations, are those available to the public?
So the full this map you see here is very similar to the heat map we produce publicly. This nodal output of the drive criteria is not available to the public. I believe we only provide a feeder level tabular analysis.
This is Timothy from Cooperative Energy Futures. I have a question about how this analysis relates to what the public ultimately sees in the heat map. Am I understanding correctly that based on this data, that if you have for example, in this case, a minimum daytime load that is below a certain threshold, that information will feed through to, for example, coloring the public map red or whatever that appropriate color would be, even if the transformer capacity of that transformer has a much higher threshold?
So there's a few points to hit there. So again, this spreadsheet analysis is taken directly into our mapping department, who apply it to a GIS or ArcGIS map, so that the outputs of drive are directly input to that map. In terms of how DML and other conditions are taken into account, I'm thinking how to phrase this, excuse me. So to your point of transformer capacity, our analysis is only on the feeder level. We do not take into account transformer capacity. So to that end, no, that is not taken into account. In terms of how DML impacts this, or how other variables impact this, yes, DML plays a part, as well as peak loading plays a part into how these analyses are performed. And I would look to, sorry, go ahead.
I was just going to hop in and discuss a little bit about, because I know there's been some discussion on just this kind of nodal analysis and what we provide on the map and what's seen. And so just to kind of clarify that a little bit here too, these results you're seeing on the screen are definitely nodal, node by node. This is the information that Drive is outputting that we use in the map. As it gets to the mapping portion, as most of you know, I believe, we have the heat map, and so it's combining some of these things in a way that you don't really see it section by section, but it does show sub-feeder results and the changes that occur across that feeder as you move further away from the substation, for instance. So hopefully that provides a little bit more clarity there too.
All right, we also have a question in the chat. Just to be clear, the hosting capacity is derived using 15% of max forecasted load. That would be the max load of the year. So two parts of that question. Yes, the max forecasted load is taken from the max load seen in the previous year. So again, back to that Gantt chart timeline, we typically see our peak loads occurring in the summer months, just due to things like residential air conditioning and factory needs. Load forecasting occurs in the fall, and takes those values, takes that peak load value from that year's summer and extends it out into the future. For DMLs, we are using actual DML data where available. So we're not seeing a universal usage of 15% as a DML value. That was just the example given in that previous screen. I hope that helps answer your question. All right, any other additional questions on Drive and its outputs?
So this is Chris again. I guess I would just like to hear maybe some stakeholders' input on this as well, because I know this is something that has come up in comments about providing kind of this tabular spreadsheet that Luther has shown on this screen. And I guess I'd just like to hear some of the values that you guys could get from this, or what you're looking, I guess, to get from this more granular set of tabular data. And if not, that's fine too. I just would like to hear a little bit more of the thoughts around that, because it's something we have, and it's part of the process, but it's also, I mean, it's thousands and thousands of nodes, probably, I don't even know, hundreds of thousands. So it's a lot of information to provide out there, and just want to be sure if that's something that people find a ton of value in. We can talk through, kind of what that would take, and any concerns around some of that info.
Yep. And as you can see, this data is output with numeric tags. So there's no real indication based on the Drive output data other than the X and Y coordinates on where the outputs are actually located.
This is Timothy from Cooperative Energy Futures. I'm not sure I have a direct answer to the question, but I think that the piece of this that I'm struggling with is just the correlation or lack thereof between the hosting capacity map, which seems like it is primarily looking, at least as far as we've gone into so far, at the node level and feeder level voltage data, and the types of information we ultimately get from pre-application reports, or previously called capacity screens, which is also looking at the feeder capacity and substation capacity. And generally our experience that those factors are also very relevant to whether an area has hosting capacity, which may be somewhat independent of minimum daytime load calculations. So it seems to me like potentially the map is presenting limitations based on one factor, whereas other factors may also indicate capacity, but it's not showing up on the map.
Yeah, and I think I'm struggling with that a little bit too, as far, I mean, they're different pieces of information. I guess that's something we've said that work together to help provide a bit better picture of what potential there is for interconnection. And the pre-app provides potentially, more information, more, kind of punch items, I guess, as far as, this is X, Y, and Z. It's pretty easy to understand. The hosting capacity takes, a portion of that information. We're not taking the substation information, and does, an actual analysis. And so something like a pre-app report doesn't really tell you voltage violations, that type of a thing. It's more, kind of a high level capacity. Even at that, doesn't always show you the total amount of capacity there, because there could be limitations further on the feeder, that type of a thing. But the hosting capacity would give you better information from kind of that voltage standpoint if you're seeing potential issues there that you couldn't get from like a pre-app report, if that helps.
Yeah, I don't feel like I have a clear response at this point. I'm just, I think we have some concerns about the lack of correlation between the information that, a correlation in terms of availability of actual hosting capacity between the hosting capacity map, the capacity screen, and what capacity is available that we actually get through interconnection agreements. And we understand that both the hosting capacity map and the pre-application or capacity screen provide different sets of data. But from a mapping perspective, for a map to be particularly useful, you know, it doesn't need to be 100% accurate or specific, but there should be a meaningful correlation between the information presented on the map and the availability of hosting capacity.
Yeah, I agree there.
Any other thoughts?
This is Brian Leidick with IREC. Can you hear me?
Yep.
Okay. Yeah, I was just thinking the maximum hosting capacity under each column would, I would think, would give you better information than you would likely otherwise have as to, what potential mitigations could be necessary if you want to exceed the minimum hosting capacity. Basically, if you know that there's the thermal violation is the minimum, then you're likely looking at a capacitor upgrade or a conductor upgrade or something like that. And you might have an idea of how other voltage regulation or something like that could take care of voltage needs.
Definitely, and that's a benefit of the added pop-up functionality, where we're now highlighting what specific criteria is being violated within the hosting capacity process. So I believe that's a great step to address that.
This is Yoki, but what's provided now only includes the, the limiting criteria, probably for the line segment. So, and sometimes there are multiple things that are listed as the limiting criteria. And so if you could know the actual values, you could see, okay, if I'm gonna, if I want a project, that's going to be larger than the minimum because it's just the voltage, but I want to stay under the thermal violation number, I could size my project to meet that if you had all the data that's in this table. But what's provided in the map now, where you only have the name of the most limiting criteria and not the values that go along with each, doesn't give you that increased information.
Understood.
And this is all, as you mentioned, this is all data that that Xcel has anyway as a result of the analysis. And I would also note, it looks like you have nodes and geographical coordinates here. Most utilities that provide this result provide it based on the line segment. So they would have some sort of line segment ID that's used, when you download that, and then you could put that line segment, the online map, type in the line segment number, and then find out where that is, and correlate that with the downloadable spreadsheet that way.
Understood. We also have an additional question from Malika, I believe. Which data source is updated more frequently, the hosting capacity map information or what's reported in pre-application reports? I've seen several discrepancies between feeder voltages in the same spots. So there's a couple facets to this. I would say that overall, pre-application reports provide a more zoomed in, focused analysis. So for that reason, it might have more frequent updates based on any conductor changes, things like that. In terms of voltage discrepancies, there has been previously to this iteration of the hosting capacity map. Again, now that includes a pop-up screen. There have been issues between sections of feeder with step-down transformers and the voltages reported there. I believe we have made strides to correct those errors as well. Chris or Ed Shannon, do you have any input there?
Hi, this is Chris. I don't have anything other than I guess we'd be interested to see where those locations are if you could send those forward too to help just going forward to make sure that there isn't anything systemic there. But there is, just to kind of echo Luther's point, feeders can have multiple voltage levels and voltage gets stepped down and stepped up, even in some cases at different locations. And so sometimes getting that information can be a little bit more difficult. So that could be some of the reasoning behind it.
All right, any other questions regarding hosting capacity results? Great. I will also mention, as I said earlier, just wanting to provide a list of some of the additional functions within Drive. As we've already talked about, one of the main functions is hosting capacity for generation, but hosting capacity for load can also be performed. An added feature has been hosting capacity analysis with autonomous smart inverters, as well as N-1 switching conditions and mitigation assessment. Any questions on these additional functions?
Hey, this is Yoki. By mitigation assessment, do you mean the assessment of the feeders with the cost to upgrade feeders with zero hosting capacity that was included in the last HCA report?
I would look to Matt Rylander from EPRI to provide further clarification. I'm not entirely sure whether the mitigation assessment is still in the final stages of planning and implementation, or if it has fully become a Drive useful or a useful tool within Drive as of yet, or if it's still being created. Could you provide some thought there? And there's a chance you're on mute, Matt, if you're responding right now.
Yeah, sorry, it mutes me twice on my phone and on Zoom. To your question, Yoki, the mitigation analysis began really a little bit before Xcel's filing last year of how to get the feeders that had zero hosting capacity up to an ability to accommodate DER. We further have refined that analysis, but the general idea there is looking at feeders that may have zero or just a limited hosting capacity. If like an interconnection request were to be greater than what the current hosting capacity is, how can we do the analysis to look across different potential solutions and see what solutions are viable to get that location to go from X hosting capacity to Y hosting capacity, and Y being higher. So it's trying to give an idea of, well, how can you get more DER interconnected or the hosting capacity on the feeder increased through several different mitigation options that we have implemented.
And I'd like to reiterate that that is a very location-based assessment. It does not work the same way that the hosting capacity analysis performs, where you can input an entire feeder or an entire substation even, and have those values calculated. The mitigation assessment requires a specific point on those feeders to say we are increasing the hosting capacity from, again, point X to point Y, with Y being higher.
Right. That's an important point there, for sure, Luther. The computational power required to do that assessment, to look across all the different mitigation options and examine the higher penetrations of DER, do get pretty intense. So it is more of that location-specific type analysis.
Any further questions?
Thanks. So it sounds like the answer is yes, this is kind of the same type of analysis that was included in the last report. And I know that Xcel paid $50,000 to EPRI to perform that analysis during the last cycle. And am I correct? It sounds like this is incorporated into the function of Drive now, and if Xcel were to use it again, would there be an incremental cost, or is this just kind of a feature that's available to all users of Drive now?
It is a feature that's available to Xcel. It's a feature that's available not to every user of Drive unless they're part of the base research that has developed that functionality. And Xcel being a fundamental piece on developing that, they definitely have access to that.
Yeah, and I would just add to that that this piece is, EPRI provided that analysis last year, and it was a time-consuming element for sure. And so if we did perform something like this ourselves, we would have to look at how we would be able to accomplish that. So it's hard to say if it would require extra costs or not at this point. We probably wouldn't go to EPRI and do it the same way. Maybe we would, but it's a resource issue on us being able to perform some of this stuff. So it's hard to say exactly what the cost would be, but we know we wouldn't have to pay more for the software in this piece of it.
Thanks. It's great to hear you won't have to pay more for the software if you want to do that again. And this seems like an appropriate time. I don't think we've had a chance to acknowledge it yet, but from the stakeholder perspective, I just want to acknowledge that performing these analyses does take a very large amount of time and a very significant effort on behalf of the on behalf of Xcel and the distribution team there, and putting together this presentation has provided a lot of detail into that. So thank you for all the work that that the team has done along those lines.
Absolutely, thank you. I'm going to open up the floor to any additional questions. That's the end of my presentation, but again, thank you all for listening. Is there any other topics of discussion or questions we'd like to address?
Well, it looks like we're running a little bit ahead of schedule. So let's do that break. We'll take a 30-minute break starting now here.
Hold on.
Oh, okay.
I do. This is Yoki. I do have a couple more questions about data validation, I just want to make space for others to ask questions so that I wasn't taking up all the airspace in case there are others out there.
All right. Well, it sounds
But
like
I
you
guess I'll just
either,
jump in.
Yep, just go ahead.
All right, great. Thanks so much. So we discussed earlier the kind of automated flags for the inputs to the Drive tool. And so I wanted to take a second to talk about Xcel's data validation process for the results that are coming out of the Drive tool and to see what kind of checks are done before the maps are published. So I guess, the first question along those lines is, if Xcel checks the feeders with, 0 hosting capacity to see if there are any anomalies or problems, before publishing the results.
So we primarily look for any significant reductions in hosting capacity, usually greater than 1 megawatt, as that is the common community solar garden size. And those are compared with last year's analysis. When we see drops of that magnitude, we will go back and compare both of the analyses, see if any DER has been added, any significant changes, things like that. For 0 hosting capacity models, we certainly check for any new 0 hosting capacity feeders. But if a feeder has already come up with 0 hosting capacity and we've found, a legitimate reason for that, which there often is, we don't further try to analyze that. But for any new ones, we certainly try to see what changes occurred. And if any of the changes are within reason or could potentially be due to some error within the model. And if so, then the model is repaired, checked, and then reran through hosting capacity.
Yeah, and just to tack onto that a little bit too, I think, Yoki, you've been aware too over the past few years too, we've done a number of different comparisons, comparing to synergy, comparing to interconnection studies, comparing to screens, and learning from each of those as well. And so we've done some of those along the way too, to allow us to have more confidence or to find potential issues too, of things that we need to address. And I think that's one of the things too that Matt's going to be talking to in this second portion of just some of the work that's out there in validating in general. And I think that will be helpful to this discussion as well.
Great, thanks. And then I guess some other flags that I think we've seen utilities use, when looking at results would be, discrepancies in the number of line sections and loading and voltage violations, and, equipment settings that might vary from those commonly used. I think that's appropriate to talk about at this stage. Maybe some of those are appropriate to talk about, earlier stages for validation. But I'm curious if Xcel is looking at any of those before publication.
So primarily those issues will occur within the model creation process, within those load flows that are performed. So when it comes to the drive analysis section, unless those settings and potential discrepancies are causing issue with the hosting capacity values and analysis, they're often not referred back to, and are just, we will repair any of those larger discrepancies and larger hosting capacity drops, but usually that portion of the analysis has already been completed before going into drive.
Yeah, and that's some
Great,
of.
thanks. So can we?
Oh, go ahead. Finish your question.
No, why don't you go ahead of the explanation?
Okay. I was just gonna highlight a little bit more. Some of the cleanup script stuff we do at the beginning catches some of those things, and then as Luther was taking you through the power flow, we've got those exceptions reports that highlight out of voltage or overloads, those types of things that help flag a lot of those issues that are out there, or things like sometimes you'll have maybe conductor that's not connected for whatever reason, or just certain oddities, and so that part of the process, a lot of that gets flagged automatically in Synergy as we run these load flows and do even after some of those cleanup scripts. So go ahead.
Great, thanks so much. And I think this will probably be my last one, and that's just asking if there are any random checks that are performed, just to say, okay, we'll maybe take some representative feeders, or maybe just take some random feeders to see if you might have some false negatives or false positives coming up as a part of the results.
So we're able to filter through our entire list of feeders in terms of their feeder hosting capacity and look for those changes. We highlight small changes in hosting capacity, large changes in hosting capacity, et cetera, and those are all flagged as part of the output summary, and provide any feedback there in terms of whether we need to go back and check a model or dig deeper.
Great. Thank you very much. Those are all the questions I have at this time.
All right. Well, thank you, Yoki. Do we have any other questions before we take a break? All right. Looks like we're ready. I just want to remind everyone that we are recording this workshop. It will be available after this live session. We'll also be providing our slides, so don't worry about trying to write everything down on, that's on the slides and all of that. You'll be getting a link to that, to the slides, as well as the recording later this week. So just watch your email for that. So it is 1:23 right now. So let's pick up again at 1:55 Central. So we're running about 5 minutes ahead of schedule. So maybe we'll let you all be able to get a portion of your afternoon back today, and maybe we'll get it done a little bit early, but recognize that we're kind of packing a lot into this session, and like I said, we want this to be interactive. So over the break, while you're taking care of other things, please be thinking about additional questions and comments that you might have. So we'll see you in about 30 minutes. Thank you.
Thank you, everyone.
Well, good afternoon, everybody. This is Matt Rylander with EPRI. I'll get started here in a moment. Paget or Chris, did y'all want to say any words first, or should I just go ahead and get going?
I don't have anything. I don't know, Jody, did you have anything you wanted to jump in with?
Yeah, I was just going to welcome everyone back and thank everyone for the questions, the good dialogue in the first half of the workshop today. We'll be getting started here with Matthew Rylander from EPRI. Just a few reminders to ask a question, either unmute yourself or type your question in the Zoom chat. Please be sure when you do unmute yourself to only do that when you're speaking. And then with your question, please state your name and your organization that you're with if that applies. With that said, I'm going to turn this over to Dr. Rylander, who's going to dive more deeply into the Drive tool and its various hosting capacity analysis methodologies and how they compare to others. Matt?
All right, well, thank you. Once again, I am with EPRI, and we have developed this Drive tool, but in a bigger context of today's topics, I'm going to go over a little bit more about EPRI, since probably many of you on the phone right now don't really know EPRI as well, and then get into EPRI's development of the Drive tool, which Luther and Chris spoke to earlier today quite well. We'll also dive a little bit into the allocation methods that Drive utilizes when calculating hosting capacity. So a little bit of a deep dive into that particular topic in the analytics of hosting capacity. And then I'll talk a little bit more generally across the hosting capacity analytics within Drive, but also within the other tools that are out there that can perform similar studies. So those are the four topics that I will cover today in today's presentation. And once again, like Luther's presentation, I'm very open to handling questions as they come about during the slide presentation. So please stop me when needed. So a little bit about Drive. Drive is a nonprofit, sorry, a little bit about EPRI. EPRI is a nonprofit organization for advancing safe, reliable, affordable, and environmentally responsible electricity to the society. And that's kind of EPRI's mission, to advance the energy sector. And through this, it's done with our members. Our members really come across the globe. They come from everyone, not everyone, but from members within the United States, members worldwide. And these members provide funding to help develop tools, help develop research, and also demonstration projects. And from that development, our members have shown us that there's a need for hosting capacity analytics. And the hosting capacity analytics in that very small subset of projects that EPRI works on, it helps create this Drive tool. This Drive tool which does hosting capacity as well as other things too. Now, Drive, we've talked about that a lot so far today, but it stands for Distribution Resource Integration and Value Estimation. And that goes beyond just hosting capacity. It's also looking at locational value. We also spoke a little bit earlier toward mitigation assessments too. So Drive really does a little bit more than just hosting capacity, but the fundamental, the use case right now, how people are really utilizing Drive is for hosting capacity assessment. And one of the things that makes Drive unique is its capabilities. Its capabilities come from being flexible. It's a tool which really plugs into all the different tools out there. The development tools for Synergy and SIME, the distribution system analysis tools that utilities currently utilize. Drive works with those tools in conjunction with those tools. So it's flexible. It's also scalable in the sense that you can do these system-wide assessments quite rapidly and get some answers back, hosting capacity in this sense, that allow you to better understand your whole system. At the same time, the capability of granularity really focuses in on being able to get down to those individual nodes, like Luther talked about earlier. The individual nodes within a feeder, hosting capacity is defined all the way down to that level of detail. So it looks system-wide, but it gets down to the specific details of a feeder, and it's flexible among software platforms that utilities utilize today. So that's kind of a little bit more about Drive. But EPRI's not in the business of creating software explicitly. What EPRI really is creating here is an environment in which we can enhance hosting capacity, analytical capabilities. And we pulled together members, our members of EPRI that support hosting capacity or need to know more about hosting capacity come together and they mingle, they talk to each other, they give ideas of, well, hosting capacity needs to do this for me or it needs to do that for me. And these ideas are coming together in this users group of Drive, which allows us to further enhance the tool itself. And that's where the members really get a hands-on on what's happening. It's a little bit different than many other hosting capacity analytics out there, which are developing more in isolation from the utilities, the ones that actually are using them. But the other really big part about the Drive users group is, big part is providing the tool and the enhancements to the tool, but the other part is bringing people together. And it's that opportunity to really provide some consistency in the messaging of what hosting capacity is, in that methodology, but also in how the analysis is being performed. And that's where our members of the Drive users group really come into play. And you can see here is a simple map of the members of Drive, the ones that are really pushing forward the analytics within Drive, come from utilities across the nation and also worldwide. The hosting capacity isn't a United States issue. It's really a worldwide issue of how do we assess how much our distribution system can accommodate for DER. Now, we pull together members and we provide consistency across the messaging and how analytics are performed, but we have to recognize that not all of these members utilize the same power flow tools. They don't all utilize one distribution software vendor. They may utilize anyone from SIME to Synergy to MillSoft to DW, Power Factory. Homegrown analytical tools within utilities also occur too. So what we have to do and what we recognize as being something really important is providing this hosting capacity analytical engine, but also the interface to all the different tools that utilities are currently using. So the analytics can evolve in a consistent manner, even though the utilities are all using different platforms to do their day-to-day distribution planning and interconnection study analyses. So that's another very important part of the Drive users group, is pulling people together, having consistent methodologies across different platforms, different tools, and having that messaging around hosting capacity being consistent as well. Now, another really important part of the users group, in which I'm going to dive into a little bit more in detail here, is how do we do the actual analytical assessment of hosting capacity? And one of the fundamental ways or influencing factors to do an assessment is how do you even allocate the DER for a particular assessment? And this gets into how that DER is added to a model to calculate what your hosting capacity, either for a specific location or a feeder, is. So what are your results coming out from this hosting capacity assessment? They're driven by how you're allocating that resource to begin with. And there's two main methods that we like to focus on and that we've found very important for our members. One is a centralized allocation method in which you go to specific locations on a feeder and you add DER one location at a time to determine how much DER, how much generation, or how much load can that specific location accommodate. And the primary use case for this is for informing interconnection. Now, I can determine at this particular location, it can accommodate X megawatts of hosting capacity. So that could be used to inform someone that wants to interconnect DER there, say, this location could accommodate X megawatts. However, there's also a different allocation method in which you could distribute the DER across your feeder. Now, as you start to pepper this DER across your feeder, you're no longer looking at a specific location and how much it can accommodate. You're starting to know how much can this feeder in general accommodate. So it's like a feeder-wide hosting capacity assessment. And that's going to result in an answer that really informs planning, because you're not going to have DER being spread across the feeder happening overnight. It's going to take years to develop this distribution of DER that's been interconnected. And from a planning perspective, we look several years out to the future to see, well, is a feeder designed well enough to accommodate more DER or more load to come onto that feeder? And that's informing planning as you start to think about in the future. But so those are the two main distributions. Those are the two main ways to allocate generation onto a feeder to calculate hosting capacity. And I have a few slides here set up to really drive that point a little bit further home. This is an example of how centralized hosting capacity is calculated, and it's that centralized allocation. You add DER one location at a time on a feeder, and you keep growing it until you hit that threshold of you having a violation on your feeder. The end result is having location-specific hosting capacity, as you saw Luther show earlier in that table. So every location on this feeder has a unique amount of DER or generation or load that could be accommodated. Now, one further point to emphasize here is when you start to think about in maps and when you start to think about how you illustrate hosting capacity, even though we're doing a centralized assessment on specific nodes, you usually illustrate this hosting capacity across areas or sections of a feeder. And for instance, we may have analyzed this last point on this illustration, this example, and it's this dark red to brown color. At the next node upstream, it was more of a reddish color. Now, in between these 2 points, there's a section that connects the points that we've analyzed. And this section really illustrates the range in hosting capacity between the points that were analyzed in our study. And you could do a similar type assessment where you illustrate the results and you have to portray those results. In this particular case, this last section on this feeder really has a hosting capacity that is a range between the red and the brownish color, because DER could interconnect potentially at any location within this section, and you have a range in which that section could accommodate if you're closer to the head of that section or further towards the end point of that section. So this is important as you understand the mapping of centralized hosting capacity results. You're analyzing at a node-based level or a bus-based level, but the results are sometimes rolled up to other elements such as sections. Now, another illustration here is for that more of a planning use case, where you distribute the DERs, that distributed allocation of DER across your feeder. And there's different ways you could do that distribution. There's actually an infinite number of ways you could do a distribution across any single feeder. Two of the ways that we've been doing this in Drive is, one, allocating it based off of existing customer locations. And previously we've defined that as distributed small, like small scale systems coming on based off of where load is. Another way to do this allocation, this distributed allocation, is based off of three-phase locations in general. And this is where you have a whole bunch of different scenarios that could be developed. And previously we've defined that as distributed large. But really, when you think about it, I don't want you to get confused with distributed small or distributed large. Really, it's just a distributed allocation that could be skewed based off of different variables, whether you're looking at three-phase locations or existing customer locations. This illustration that I'm going to click through here, you define a distribution, and from that distribution, you get this feeder hosting capacity for that distribution that was analyzed. So they're tied together. You have a feeder hosting capacity when you're doing hosting capacity in this manner that is tied to the distribution of DER you're considering. Now, it'll change. If your distribution were skewed towards the end of the feeder, you may have a very different hosting capacity as a result. Or if it were distributed based off of customer location, perhaps, you'd have a different hosting capacity. And the key point here is your distributed hosting capacity. One of the potential results is very tied to whatever distribution was considered on the feeder. And once again, this is that planning focus. This is not currently what a lot of utilities provide maps for. You know, the maps that we've been seeing in the industry are based off of centralized hosting capacity, where you analyze each location specifically to determine how much it can accommodate. But what I wanted to portray here is that there's different ways in which you can calculate hosting capacity. Now, moving forward further, as something that we have seen our members find interest in and have helped advance the analytical capabilities further, is what about combining that distributed allocation and the centralized allocation to get not only that interconnection use case, but also a planning use case out of your hosting capacity assessment. Now,
just a heads up, Matt, there are a few questions in chat.
Oh goodness, yeah, thanks, Luther. Let me see those before let me move backwards actually. So the first question in chat, and this is no problem, I think I'm ahead of schedule. If you wanted to cite DER in the blue area of the section represented in the centralized hosting capacity, so let me go back one more. Would the DER you wanted to interconnect be limited to the brown area of hosting capacity, or could you use the blue area's hosting capacity? Yeah, so this gets into the node level results. So this area of the feeder, this section, could accommodate a whole lot more DER than the end location. And this is a good point that I didn't really get to. This hosting capacity is calculated independently of the hosting capacity out here. So if you were to put this dark red amount of DER out here towards the end of the feeder, if you were to put that much DER, the hosting capacity of the entire feeder would have to be recalculated. At each location would have to be recalculated. And if you put this much DER out here at the end of the feeder, technically your whole feeder's hosting capacity at all locations would go to zero, or very close to zero. So what you see in this map is that the locations near the head of the feeder can accommodate much more DER than the areas towards the end of the feeder. Now, it doesn't always very linearly decline head to the end of the feeder. You could have elements in there like a thermal constraint, which hosting capacity rapidly decreases really quick. So you might have more of a discontinuous change in hosting capacity. But the answer to the question is you would be able to accommodate much more DER up here at the head of the feeder than towards the end of the feeder. Now let's see the next question. Are both of the distributions performed using a stochastic randomized methodology? So the centralized hosting capacity marches down the feeder and analyzes each location independently. So there's no stochastic nature, there's no random assessment being done there. It incrementally goes from one location to the next to analyze each location towards the end. Now, your distributed hosting capacity can be done in many different ways. Here I spoke to a couple examples of, do you distribute it based off of customers? Do you distribute it based off of three-phase locations? You can also distribute it from a fashion in which you set that allocation and then you grow the penetration of that allocation. Or you can also do it from the sense that you are more stochastic in selecting a few customers. Then to get to the next penetration level, you select a few more customers and a few more customers and a few more customers. And those are all different methods in which you can conduct a distributed hosting capacity assessment. And we started in Drive specifically in a more stochastic nature. The analytics and the computational time required to do a stochastic-based analysis is much more intense than doing a grow-based allocation. So there's different pros and cons, and how you would need to do a distributed hosting capacity may be more important doing stochastic versus more important doing it from a grow-based method. So those are all different variables within that hosting that you have the ability to evolve and define. What does it mean to do distributed hosting capacity? So that brings me to my next point. I think I covered those two.
It seems like we may have lost Matt. Can some people hear Matt talking?
No.
No.
Okay. I was hoping it might just be me. All right, well, we're gonna have to figure out how we can get Matt back online. Please bear with us for a few minutes.
Anybody able to hear me now?
Yeah.
Yep.
Sorry, guys. Of course, it happens to me. All right. So where did y'all lose me? Back here?
Yeah, man, I think it was right when you switched to this slide.
Okay, perfect. All right. Well, at least yeah, y'all got me stopped relatively quickly before I went on too much. So where the Drive Users Group has really taken us is there's also a need to not only look at just distributed hosting capacity or just centralized hosting capacity, but there's also a use case in looking about combining those two allocations together, where you would first like to say, well, what about forecasting amount of load or generation? In this case, we're really focused on forecasting generation onto a feeder. But then with that forecast in mind, kind of that planning perspective to say, well, there's going to be some distributed DER out there in the future. Residential DER is going to come on, and I don't want to limit the amount of distributed DER, those small types of DER coming on. Reserve an amount of capacity to host those small DERs, but still determine our interconnection focused hosting capacity capability today, where you would take that forecast, layer it in, and then secondly, complete the hosting capacity assessment from that interconnection point of view.
Hey,
now,
Matt.
It does have it. Yes, ma'am.
It's Jody from Xcel. It looks like we've received a request for clarification from Yoki in terms of his question around the stochastic methodology as it relates to the EPRI methodologies. You can take a look at the chat and clarify.
Yeah, so it does the small distributed and the large distributed, and really in a general sense, they're just distributed hosting capacity assessment. Is it stochastic in Drive right now? It is not stochastic in Drive because we aren't reallocating to different customers, different locations independently from one another. Now, for a true to stochastic analysis, you have to define your seeds in which you are going to allocate. You would have to define also where the customer or where those future customers are going to be potentially connected. And you have to define what size those future potential customer locations would be. So there's a lot more variables that get pulled into a true stochastic analysis. And those are really important from a planning perspective to go out and see, well, if these customers were to accommodate, or if these customers were to get DER first, and then these next customers to get it, and these next customers to get it, how would that hosting capacity correlate? That's a very important and unique type of methodology. And it's something, dating back to what, EPRI's been doing years ago. It's an important planning assessment, but it's a very complex assessment in itself too. So Yoki, really for the simple answer is we do not use a stochastic distribution where we're going to assign DER to one location and then assign DER to another location or another location and grow penetration based off of who gets assigned, how large they are, and when they are assigned that DER. And that, I'm getting into territory in which it gets very detailed in what a distribution is, or a distributed DER assessment. And I don't want to get too tied up into that, but those are important methodologies that can be considered for distributed DER.
Thanks, Matt. This is Yoki again. I appreciate you saying that it's not stochastic. So I feel like I understand what it is not, but I don't understand what it is. And if Xcel isn't using this now, but I think if Xcel is going to think about moving towards using this, that detailed conversation is something that we'd be interested in having, so we can understand exactly what it is. And if Xcel's not proposing to move there right now, then I don't know that we need to take the time to get into those details. But if Xcel is thinking of moving there, then I think that would be a valuable use of our time.
Yeah, and I'll just summarize real quick from the distributed assessment, this allocation. The way that it's done is exactly as you're seeing in the animation right now. You define the allocation and you grow the penetration across that allocated location. So you assign what customers might be getting it, whether they're skewed towards the end of the feeder or if they're based off of existing customer locations, and you grow the penetration to determine hosting capacity. And within Synergy, the distribution software platform Synergy, they have a similar assessment, and it's coined GROW, hosting capacity versus based off of a GROW assessment. And that's why I'm trying to use a consistent terminology across tools, where this is more of a GROW-based hosting capacity assessment versus a true stochastic-based assessment.
Yeah, this is,
Gotcha.
if you don't mind me jumping in just for a second, maybe to give people a little bit more history here too, and what we've done, and kind of some thoughts as we go forward here. We did do this distributed hosting capacity method with our first analysis. And it was really based on kind of this green feeder that Matt's showing, that type of looking at where customers are, growing it at those customer locations, and then doing the analysis, and providing that output there. We switched to the one prior to this, where we're talking more about the centralized methodology, and we've done that the last 3 years. And so, that more closely aligns with kind of what we're seeing in Minnesota as far as solar gardens, these large chunks of generation that are being added. And so as Matt gets into this next slide where he's talking about kind of this combining of the two, that's where we really wanted to see feedback from people, because that was one of the comments I think we've received in the past, of especially this last year, is there something in the middle that stakeholders should discuss a little bit more with us at Xcel, if there's some value here that we can agree on and move forward with. So that's kind of where we want to just try to tee that up a little bit, where we want to go with this. So I think it is good to understand how these work, to your point, Yoki, because we do want to see some of that feedback and what you guys are thinking as we get to this next slide.
Gotcha. Thanks, Chris. So you're saying, so if I can just recap, does that mean that the user defines the distribution in these in this methodology?
Currently for this methodology in Drive, the user defines the distribution, how to allocate that DER when performing your hosting capacity assessment. So they have the options of like 3-phase locations, they skew towards the feeder head or skew towards the feeder end, or based off of existing customer locations. So how to allocate that DER in that GROW assessment defined by the user of the tool. Now, one thing I did want to clarify too is the early versions of Drive, when Xcel originally did a distributed small hosting capacity assessment, it was stochastic at that point. But the users group which again, I'm kind of reiterating the importance of this users group, is they've really shown us what is the best way forward. Do we need to do these detailed stochastic-based assessments, or from a planning perspective, are these more of a grow-based distributed DER allocation more applicable? And so the functionality, the evolution of the tool itself has really morphed over the years based off of the users group input and how to perform these analyses to provide something back that's more usable, something that's really something you can use in a planning-based scenario. So that's how the tools evolve, and that's why I didn't want to say stochastic, something that you'd want to rule out. If stochastic's important, you can do that distribution, that allocation, and assessment that way. But it's just one of the many ways to do a distributed hosting capacity assessment. And there's really no one right or wrong way. They're all giving you insight into that planning perspective, whether it's growing-based DER and its hosting capacity assessment or stochastic allocation-based hosting capacity assessment. They're all important, but have fundamentally different analytics that go within the tool. Yeah, great questions. I know it's really hosting capacity in general. I always say this to most people. The analytics are very involved. There's a lot going on there. It's not just you click a button and run something. It's like what Luther spoke to earlier. You set up the analysis to find what types of scenarios and settings you want to analyze within that assessment. And that gets us back to this particular slide that I'm showing now. You could even do this assessment where you first define an allocation. And we're not talking about growing. We're not talking about distributed hosting capacity in the sense that we're allocating it out and growing its penetration level. Here, what we're truly doing is saying, in 5 years from now, I think that there may be distributed DER on the feeder, distributed, probably residential DER. There may be 1 megawatt of that DER out there. So you can say, well, I want to retain hosting capacity. I want to reserve that ability to accommodate that distributed DER. And for the larger sites that may want to interconnect more immediately, we'll run this assessment to say, well, how much can be accommodated right now based off of reserving that margin for the future, for those other guys that are going to want to come in and not be limited because there's too much already on the feeder. So it's another one of those possibilities within the hosting capacity assessment that may be useful from a planning perspective, making sure your feeder will retain a margin to accommodate DER, but also provide hosting capacity for interconnection study-based focuses today. One of the caveats here that's really important, though, is this last little bullet on this slide, is how accurate can your forecast really be for several years from now? Do you know who's going to have the DER, where it should be allocated, and do you know to what penetration level will that allocation even be? So if we distribute it based off of customer locations, maybe that's your allocation, but do you think that there's going to be 1 megawatt? Do you think there's going to be 2 megawatts in the future? Those all have a fundamental factor when you calculate your remaining hosting capacity for today. So a lot going on there. These are all analytics that are evolving. But the two that I wanted to dive into here more deeply was that centralized based allocation and that distributed based allocation. How you would use those for interconnection studies. You're focused on that centralized based allocation where you're looking at one location at a time and seeing how much can that location accommodate? Distributed is that planning perspective to really understand how much could this feeder accommodate. And you could use it towards building out the feeder. Maybe a feeder from a planning assessment can only accommodate 0.5 megawatt, but you want to be able to build out the feeder to accommodate more. So there's really more of a planning focus for that distributed hosting capacity assessment. But then there's also this combined nature of distributed DER plus centralized DER, and setting aside an amount of DER that can be accommodated in the future, and then limiting your current hosting capacity results based off of whatever interconnection capacity you want to have in the future. So a lot of possibilities, and once again, I'll say this is an evolving area. It's evolving to say, well, there could be other forms of analytics in the way that the allocations are divvied out across the feeder. How many different allocations are considered? If you were to combine distributed and centralized, you could look across many different, even stochastic-based allocations. Maybe it's a focus on 1 megawatts in the future on a feeder, but you want to consider 1,000 different ways, 1,000 different ways that different customers could have been accommodating that 1 megawatt. So if you think about a feeder that has maybe 5,000 people, customers on it, there's a lot of different ways to allocate out DER to those 5,000 customers. So a lot of possibilities there, a lot of room for future evolution of hosting capacity analytics to capture some of these impacts. I'll stop there. That's kind of the first main part of this presentation. And then I'm jumping into the analytics and tools.
So I guess just kind of reiterating what I said before, hoping there's some discussion here and some feedback on just how this, if we want to talk about further changing how we do some of these distributions. I know it's kind of a pretty detailed topic, so maybe there isn't a lot of discussion here, but just wanted to make sure that you guys had the opportunity to talk through this a little bit more if you wanted to. I mean, I think just kind of highlighting what Matt said, the methodology we're using now, or the distribution we're using now with that large, or with the centralized distribution. I mean, it's really kind of interconnection based. The distributed allocation, more planning based. We could kind of bring those together into kind of a combo where we essentially carve out a little bit for planning, and then we do the analysis like we've been doing it the past few years. But there'd have to be some assumptions in there, and we're not doing detailed at this point DER forecasts at the feeder level. That would be information that's where we'd have to kind of make some assumptions and do some stuff there. But that's kind of the thinking here, at least.
Thanks, Chris.
Well, I guess sorry, Chris, that was an invitation for feedback on which methodology Xcel should consider using in the future?
Yes, exactly.
Yeah, great. Yeah, I can speak from IREC's perspective, and I'd certainly like to hear from other stakeholders as well, especially I know that Commerce has asked about this as well in the past, if I remember correctly. Apologies if I don't remember correctly there. But really, IREC has consistently since our first paper on the topic focused on really identifying your use cases. And I think the slide you have up here is a really great example of why it's really important to be clear about what use case you're looking to solve with performing a hosting capacity. To this point, Xcel's been using the centralized, which is best for the interconnection use case, and IREC agrees with that. I think that we see this as a valuable interconnection tool. To the point that if stakeholders and Xcel and the commission want to continue this to be a tool for interconnection, it seems like centralized is the place where it is appropriate to use Drive if you're going to be focused on that interconnection use case as we have been, and as I think is of the most immediate value to developers.
Thanks, Yogi.
Yeah, and then I guess if we were to use or if Xcel were to use the distributed or one of those hybrid methods, it seems like there would need to be a lot more discussion, maybe in the next workshop about what assumptions would be used around the distribution, so it could be vetted and understood how the distribution was being done and what use case that distribution was hoping to serve. I can't really think off the top of my head what use case that might want to serve, but if stakeholders have an idea of a specific use case that they'd like it to serve, then I think that's a good jumping off point for a conversation about how the distribution should be done and what assumptions would go in there before diving in and deciding to use it.
Yeah, I think those are good comments, Yoki. All right, I'll keep moving forward, Chris. If you want to say anything else, just stop me and let me know.
Okay, thanks, Matt.
Yeah. So the second part of my presentation is now getting a little bit away from the analytics specifically within Drive, but really looking at hosting capacity and analytics across tools themselves. And there's different tools that can do hosting capacity. I always like to point out that there's a difference between the actual analytics and the entire process, the hosting capacity process. What Luther was talking about earlier today really captures that complete process that's included in doing this type of study. And that involves getting into the input data, the model cleanup, the model validation, all of that prior to the actual hosting capacity analysis occurs. But it also is important to focus and understand what that application, that use case is as well. And Yoki, you mentioned this too. If you're going to be doing hosting capacity for a interconnection-based use case, the input data that's required, the analysis settings, the analytics that are performed have to focus on providing the results that would be most applicable for interconnection. Now, if your focus is on planning for in the future, you have more assumptions. You have different types of allocations of DER that are considered. So the entire hosting capacity process is complex in the sense that you need to understand the inputs, you need to understand the analytics, and you need to understand how those results will be applied. And that process has been refined. It's continuing to be refined based off of stakeholder meetings like we're having today, but also from tool vendors, utility guided input, and the regulatory processes have really helped formulate and structure that process. But it's a big process, captures a lot. Now, the analytics, though, which I'm going to talk to in this last section today, is focused really on this, the analysis itself. And there's a whole different evolution of analytics that is happening in parallel. So you have your input data, you have your analysis and applications, and this process, this kind of defines the process of hosting capacity. And these things have been defined, they're being defined, but you also have the analytics that are going on within the tools. And how those analytics are being done is a little bit, it's not quite as transparent, to be quite honest. And to understand exactly what a software tool is doing, you have to get into that code. You have to understand what the code is doing. And the ICA version, the interconnection capacity, integration capacity analysis in SIME is being done differently than interconnection capacity assessment in Synergy. And Drive has its analytical engine as well. And these tools have evolved separately from the process, but they have been evolving to meet the needs of the process that is defined. In some cases, the analytics are being well informed by the users group in Drive. In some cases, they're being informed and evolving more based off of what the tool, the vendors themselves, think that the tool needs to do and how it needs to do the assessment, which is kind of what you would expect. But having a greater vision and understanding of that analytical engine being a tool that's evolving within these software tools, it's like a module within these software tools. It has an evolution process. And to really drive that point home a little bit more, I like to always pull us back to where we were almost 10 years ago. Almost 10 years ago, EPRI, and this is kind of a flow chart of where EPRI's been versus some other California Distribution Resource Plan requirement was assigned in California, how these processes have evolved. For instance, for EPRI, almost 10 years ago, there's a need by the utilities that came to us saying, well, how do we understand if our feeders can accommodate DER in the future? And at that point, it was a very stochastic, detailed assessment where you did that distribution, added more customers with DER until you found your feeder could no longer accommodate anymore because we have some violation exceeded. We saw that was so detailed. The evolution of this tool then said, we need to do something that can provide results back to our utilities, our members that are asking this question, faster than we were doing from a stochastic base. And to give you perspective, when we did the stochastic based assessment back 10 years ago, it was taking a month to analyze one feeder to the level of detail that we're taking it to. We found ourselves at a place where we couldn't tell the utility, well, I can tell you all you need to know about feeder X, but I don't know about feeder Y because I didn't analyze it. So we had to reformulate that assessment. We streamlined it to make it a little bit more quick. At the same time, the California Distribution Resource Plan was going to their utilities, their utilities, PG&E and Southern Cal and San Diego, and said, we need to provide hosting capacity assessments across our systems. And PG&E was, they were working and they had visibility in what we were doing. And they said, well, let's do something a little bit more streamlined. Southern Cal and San Diego, they also had visibility. We were working with them, but they were taking more of this iterative-based route. Well, the use case at this point was interconnection study. So it was more of that detailed assessment where you needed to get to a very good answer for a particular location. So ultimately, they went along the route of saying iterative is a little bit more correct compared to streamlined. And we were also aware of that too. We were trying to do a system-wide assessment, but not thinking about it from a specific interconnection-based use. However, seeing the need in California also made us reformulate our idea, evolve our analytics and drive to say it needs to be as accurate as possible, because there is this interconnection use case, as well as what we originally intended the software to be is more of a planning-based tool, where you want to take into consideration a lot of unknown variables and do an assessment. So it had this hybrid approach where you have to do things system-wide, be able to analyze these different scenarios, but get down to that granular level of detail, which I spoke to early on in this presentation, of getting down to those results at a node-based level for that interconnection use case. Now, this hybrid tool we call Drive at this point, and Drive has further being refined through that users group use. From all of our members saying, well, I need it for this or I need it for that, we need to evolve it to look at these variables or these impact factors. Now, the tools that have evolved in the planning tools, the methodologies, the analytics that evolved in the planning tools, they have also come from that iterative base point of view. But as they move forward in time, the input from the members is not quite as tuned in as it might be for the Drive users group, which I think that the vendors are probably working with utilities. And sorry, can't speak to all the vendors explicitly, but the tools evolve. The tools evolve, and whoever's providing insight on the evolution of those tools are really important. And it's important to have these analytics evolve in the best way possible, but keeping the use cases, the underlying needs of the utilities in mind, especially for hosting capacity analytics. I'll pause there for a second. Look, there's also a question in chat. So the question is, does the input for the analysis build up with experience at each feeder? So the evolution of the study has built up from prior experiences of knowing what is important. I wouldn't say that the analyses for 1 year on a specific feeder has been built upon the results from a previous year. And let me reiterate that point real quick. So when you run a study, every time that model gets updated, the results are going to be based off of that new feeder model. And cross comparison to say, well, what was hosting capacity in a previous year? That's something Luther got to earlier to say, well, we check to see, does hosting capacity go up, go down, what happens with that? But the actual analyses are not tied to previous studies on a feeder. But if you want me to get into more detail, I will. The analyses throughout a feeder do depend on that current analysis being conducted. Now, what I mean by that is these analytics within the hosting capacity assessment is smart enough to say, well, what do I know about this analysis I did on feeder X node Z? Sorry, that's a terrible analogy there. I'll say it again, different way. On one feeder, it'll look at what the hosting capacity assessment in that centralized based allocation was on node X, and it will apply the knowledge of what the hosting capacity was there when it starts the analytical analysis on node Z. So there is a learning part within these analytical engines that say, well, what do I know about this feeder already to start and refine my analysis and evolve these analytics within it? And my colleagues on the phone probably wouldn't want me to say this, but it's more of a machine learning type approach where you learn from your analysis to make your analysis better as you move forward. So So it's real interesting. Sorry, you're getting me off onto a spiel there. The analytics are something that has been being refined and continuing to be refined. So another difference between analytical capabilities, and here, this was called out explicitly to go over in this call today. The criteria in which hosting capacity is being conducted for is different between different tools. A lot of the main types of analyses, like when do we hit an over voltage on our feeder, letting that be a criteria in which we define hosting capacity for. That's something that's being done pretty much across all tools. I'd probably say it is being done across all tools. Thermal implications, how much can I accommodate before I hit a thermal rating? That's something that's also being done across tools. But then you have different types of analyses where you'd want to say, well, what about impacts to regulation devices, like voltage regulators? Am I going to cause a regulator to start to tap more often than another? There's a lot of criteria within a hosting capacity assessment, or could be within a hosting capacity assessment, and that differs between tools. Whether it's drive or synergy or SIME or power factory, what all they take into consideration to define hosting capacity is different between analytical tools that conduct those methodologies. And really, what's being included in different hosting capacity assessments across the nation and worldwide are all based off of what the particular utility wants to include. So in some cases, the utility may say, I want to include primary voltage deviation. Another utility may say, well, that's not a factor that I want to consider in limiting the amount of DER that I can accommodate. Similarly, with protection-based metrics, a lot of utilities say, well, that will have to be dealt with through a detailed protection study. But here we're also trying to get some level of understanding, would protection potentially be impacted on a feeder? And those types of analytics can be within a hosting capacity study, or they might be something that's reserved for a more detailed study and not be included under hosting capacity at all. That's another difference between the tools themselves, what's being considered. Now, it's important to understand the comparisons between hosting capacity analytics. The ones that I just showed on the previous slide, it's important to see how do tools, what are they analyzing? But even one step deeper, or maybe I should say closer to 10 steps deeper, there's a lot more details within a hosting capacity study that aren't even being reflected back up to the user. And some people, distribution engineers, will understand the concepts that I'm showing in the slide right now. But how are we characterizing the resource by which we're calculating hosting capacity for impacts? Now, how we characterize that resource impacts your ultimate hosting capacity result. In one tool, it's being done with constant current type resources, and that will lead to one hosting capacity result, versus a different tool is using constant power resources, and that will provide a different hosting capacity. It's because the characteristics of those devices have a fundamental impact on the response of the feeder. But these types of variables, which in most cases are hard-coded within the analytics, and they're both correct, they're both wrong at the same time, but they have a fundamental impact on your hosting capacity. My point here is that it's important to have this ongoing comparison to know how different tools calculate the hosting capacity analysis differently. And having that understanding will help you understand what your results are really showing. It'll help you give you more confidence in talking about those results and understanding. But there's not one right way to do it, and there's not one wrong way to do it either. And this ongoing comparison needs to be done just to better understand how vendor software tools are doing hosting capacity versus one versus the other, put it that way. Now, on a side note, what is also really important is the individual validation of the tool's methodology itself. And I can really only speak towards Drive because we developed Drive and we're continually validating these results through detailed studies. And we're doing that to make sure that the analytics that we're implementing within our analysis make sense and they are providing the results that we intend them to provide, and we understand when the results are different, why they are different. But a detailed study is very different than what you'd say any one hosting capacity methodology is doing, because in a detailed study, I set up exactly the characteristics of that future DER. I set up exactly how I want to even analyze my study. And in most cases, a detailed study would be taking whatever hosting capacity results you have, say from Drive, plugging that DER with the characteristics you want back into your analysis and seeing, well, was that truly our hosting capacity? Do I see a violation occur? Am I close to the violation or am I way over? And to be quite frank, validation is a complex process, especially as you're doing an analysis across thousands of nodes using using many different criteria as your underlying metrics for hosting capacity. But it's important to do. And it's a validation that's being done routinely by EPRI, but it's also something that we need to work closely with the vendors too and formulate a way to make sure we can all validate and explain the results that we are seeing from our hosting capacity analyses. For this particular slide, it's mainly to show that this is an ongoing validation effort by EPRI, and through Drive, our enhancements every year, to understand, are the results as we expect. Now, in conjunction with this, it has been requested, for Xcel to go and validate their results for hosting capacity through internal studies. Now, this is a little bit harder to do. I got to admit, this is very hard to do because they don't quite, know every single little nuance and detail. Even though it's a little bit more, we try to be as transparent as possible. The way that it's set up in a detailed study might be quietly different than the way that it's done, within Drive. But what has been done has really accurately captured that there are maybe some small nuances between settings within Drive versus the detailed study, but the ultimate difference in results are really quite close, which is, a very good analysis that keep in hand to understand and give you confidence in those particular results. And sorry, I can't speak entirely to this table that I got from Xcel, but this is something that I think was provided previously in filing. So it really gets me to my summary of analytics. I think this part of this presentation is really, really important for people to understand as they start to think about different hosting capacity analytics and how it fits into this overall process. Analytics are just one part of that larger, complex hosting capacity process. But the analytics that are being done are really evolving. They're evolving themselves. They're getting smarter. The way that the analyses are getting done, and they're evolving in every tool set. I speak to some of the vendors, and the way that it's being done in version, X.1 is different than it's being done in X.2. And that just goes to show that the analytics, the capabilities, the functionalities are enhancing. And it's an ongoing process that needs to be vetted. It needs to evolve. The member feedback, the Drive users group, kind of harping on that quite a bit, but that feedback from the utilities of what needs to be included, how does hosting capacity need to evolve, is really important, and it gives that transparency that it's hard to understand entirely what something as complex as a hosting capacity analytical process does, but it gives as much transparency as possible to that assessment. And finally, validation. It needs to be done, by the software developers. I think it's really important. And, just to drive the point home one final time is, that ongoing validation and comparison. We're seeing more and more important to do that sort of thing. And moving forward, I think that's something that we're going to have to really work closely together. Not just EPRI and Drive, but working closely with the software vendors that are doing these analytics. So we're all kind of speaking one voice and having a way to discuss our results and portray our results. Because the only ones that understand it the best, the analytical capabilities, are the ones that are developing it. I'll stop there. I know I kind of probably went down a little bit of a rabbit hole, but I think it's important to understand the analytics across tools, how they compare, how there are underlying differences that we need to understand, but the validation of the methodologies themselves are really what's important here.
Hi, Matt. This is Yoki. Thanks so much for the transparency provided in this presentation today, because it does provide a lot of really good information that we can use to understand the Drive tool and how the different methodologies work. To the extent that there's the new hybrid feature that we haven't had a chance to look at before. It was great to get that that detailed explanation of how it works. So thank you for that. The transparency related to the validation studies has been a little bit less forthcoming. I had a back and forth with your colleague Lindsay in a meeting before the Colorado Commission a couple of weeks ago, and she mentioned an interest in public these like you can get access to them. We know based on Xcel's filing that it costs $30,000 to join the Drive users group, and that's not something that many stakeholders have the ability to pay for. And so I guess I'm wondering, if you could publish your most recent validation work and commit to looking at publishing, future validation work to the public as well, because that would really help us have more confidence and help us engage in that conversation with you. And without that transparency, it's really tough to just kind of trust what's being said. We have no reason to doubt what you're saying, but it always helps to have the transparency and to actually see the validation of the data behind it.
Yeah, and to be consistent, Lindsay's response was, later this year we're going to be working on a publicly available validation, which we'll do for our latest release of Drive. It's something that we'll continue to do through an annual process as well. And to go one step further, I really think it's important that we don't just get the Drive validation and the Drive capabilities involved, but also bring the vendor tools and their analytical capabilities together to really further understand and see how their tools are evolving and the results that they're producing, to really have a consistent understanding across all tools, all validation of different tools to really get better. So yeah, to your question there, Yoki, definitely, we're going to work on something later this year with this next release of Drive, publicly available validation, but then continue that to be something done annually with new releases and coincide with the different tools that have capabilities, because different tools, as much as people want to understand that they're doing things a certain way, I think it will provide a little bit more clarity of how analytics are being handled within each individual tool, because it is a complex process that that needs to have more transparency. I agree. So we'll work on that for sure, Yoki.
Matt,
Great, thanks. Yeah, and the others.
Oh, this is Jody. I was just going to ask a quick follow-up there. Matt, are you aware of any effort to have all the software developers get together and do something like that, to have a validation, kind of across the board validation?
So, can y'all hear me? Kind of sounded like it cut out.
You're there.
Okay. I didn't want to start talking. Everyone doesn't hear. So have we talked to other vendors? I talked to Sime a couple days ago, and I think it's something that will be of interest to them. It's something that I think will have to get vendors on board with the thought process behind it, but it's something that we're going to push forward with through the Drive users group, because that's the platform, that's the forum in which we're not just trying to deliver Drive, but we're trying to provide consistent voice behind hosting capacity to understand it. Whether it's Drive or not, we need to really have a better understanding nationwide and worldwide that tools, what they're doing, how it's being done, what's being considered. We've started working on that independently, but it's something that we really need to pull the vendors in together with us, because they're the ones that understand their tools the most, and we can't talk to what they are doing without them being involved. And if we do talk to what they're doing, it's going probably to be not as accurate as it should be. So we want to get them involved, and that's something that we've already started reaching out to the vendors, and I think there is going to be a path forward there.
Thank you for that, Matt. Yoki, apologies, I think I cut you off there with that follow-up, so just go ahead.
That's okay, no problem. I guess I just wanted to point out that one of the things that's been tough to follow that went over well and transparently in this presentation was the evolution of the Drive tool and how it changed from using a stochastic methodology to now something that is more user defined for the distribution. And I just wanted to cite that as an example where documentation of that evolution of the Drive tool wasn't available to stakeholders, and it made it difficult for those of us who want to engage in the conversations about which methodology to use to be fully informed as we're having that conversation. So again, really appreciate the transparency provided in today's presentation, and encourage as much of that as possible moving forward as well.
Thanks, Yoki. One additional comment that I'll put out there too, when we talk about validation and working with the vendors, because there might be vendors on the call today, I'm not sure, but there's like a standardized feeder that we also want to kind of move down the lines with as well. So when we do validation, it's not going to be they validated on one feeder, a different feeder is being used over here. It's more like an IEEE standard feeder to perform validation on. I think that's an important thing to mention, in case there are any vendors or anyone on the call right now who would want to know more about that.
And I think Brian Leidick, our engineer, can chime in if he has some thoughts on this too. But I think, you know, it's also important, you know, we have these standard feeders that can be used, but I think it's also important to take a look at, you know, the processes and the feeders that are being used by specific utilities as well, because standard feeder, you know, might be representative, you know, nationally, but may not be representative of feeder configuration on a particular utility system, which is why we think it's helpful to have validation efforts that happen at the utility level as well.
Yeah, I mean, validation across the board is important to happen, whether it, you know, wherever it takes, but there are kind of those, like I mentioned on the previous slide, of, you know, being aware of the tools and how the analytics are being performed, but the validation across the board of wherever it's being conducted is important. And one of the simple ones that we end up doing is we run the analysis we pick out a location and we plug that back into the detailed study, and we say, well, is that you know, really caused the violation that we're expecting it to cause? There's one more question that came in on the chat. You know, can we count on the evolving process to speed up the time it takes to complete validation to capacity host DR? So, you know, can it speed up the evolving process? Could probably speed up, you know, some validation effort. You know, that could be a loop within the study itself to validate the, you know, particular locations within a study. Validations in a nutshell are really supposed to give you more confidence in the result. You know, prior validation is supposed to give you more confidence in the results that you are seeing through your study. In the overall evolving process, and if it'll speed up time, the process is becoming much quicker today than it was in the past. You know, going back 10 years, my point that I made in the evolution before is it would take months to conduct an analysis on one feeder. If we can evolve the process so that the actual analysis is quicker, more quick, then ultimately the time it takes from that Luther was getting at earlier, it would reduce the time it takes for the entire hosting capacity process. So analytics speeding up will improve overall process time in the end. So that's part of that evolving analytical capabilities of how is the hosting capacity being conducted. And that gets down into a lot of the details of iterating between penetration levels to conduct DER hosting capacity assessment and things like that.
Hey, Matt, is that standard feeder that you talked about available publicly for independent researchers to look at as well?
Currently, it's not. We had been talking to getting it as an IEEE type feeder, you know, making it a publicly available feeder. We have shared it with some of the software vendors who have that feeder, but it's not yet a publicly available site where you can just download it and use it currently.
So if there were other researchers interested in using it, they should contact you?
Yeah, we've been talking about how to get it, you know, as publicly available, because obviously once we share it with Thyme, Synergy, the other, you know, vendors, the idea is to, you know, have it out there to do research studies with. So that's something, you know, right now if someone contacts me, I probably wouldn't just send it right out, but that's something that needs to be addressed too, and that'll happen through this validation effort moving forward.
What are the impediments or what are the things that you're thinking about for the reasons why that wouldn't be shared with, you know, a party wanting to do independent validation?
Yeah. One of the main reasons, to be quite honest, is you put a model out there and it quickly evolves into something else. Someone may change the impedance of a line or change, some sort of characteristic. And the fear would be is that you start sending out one-off models and quickly they become 10 versions of the same model. So you really need to have kind of a central site to have this perfect, pristine model that you can always go back to and pick up kind of that very clean model. The other part of just sending out that is we're still constantly seeing that kind of that standardized model needs to be tweaked in certain ways so that we capture the different impacts of devices, like adding a regulator into a model. So we actually capture the way that regulator and its impacts on the hosting capacity results would occur. So there's components within a model that need to be tweaked, added, and changed before you get that standardized model to say we're there, publish it, write a report on this is your model, and it moves forward. Kind of like the IEEE models for the 13 bus, 123 bus have really evolved. And honestly, that'd probably be something that once we start working with the vendors themselves, they're going to have input to say, well, this model needs to capture these characteristics too. So I don't want to jump the gun, and that's the main point. Is I don't want to jump the gun and say here's the model, because it may be different before we get to that point to say this is the standardized model.
Thanks.
Yeah, it's a good question. I mean, quite frankly, it's not some special little thing.
Do we have any additional questions for Matt or for others? Anybody want to share some thoughts for this afternoon, or even from the first half of the presentation?
This is Timothy from Cooperative Energy Futures. I was hoping that you could share a little bit of an overview of how what we've talked about today, kind of on the back end, relates to our next session coming up in a couple of weeks. And I'm particularly looking for clarity on how you are gathering feedback and how we will collectively be able to review feedback from stakeholders on how to update the process.
I can speak to, I would ask probably Chris or Luther and Matt probably as well to talk about how what we've talked about today relates to workshop number 2 that'll be on June 16th. I would say it's a deeper dive into part of the analysis. It's going to be looking more at the specific values that are used for the criteria and the thresholds and the inputs and that kind of thing. But they can talk more about that. In terms of the feedback that we get, we're going to be taking that and incorporating that into our approach for our 2020 analysis, and we'll talk about it as part of that filing. That would be our general plan. Yeah. Chris, Luther, Matt, anybody want to add anything here about session 2?
This is Chris. Yeah, not a whole lot. I think you covered it pretty well, Jody. It's just we're going to look at some of those, as Luther showed, that kind of thresholds and those settings. Pick apart the ones that we use and talk through those and why we choose those values. And also talk a little bit more about our modeling process and how we choose what models to be redone on a year-to-year basis, that type of a thing.
I guess I would just like to request, in terms of the feedback portion, that we have a process for kind of shared documentation, like visible to the stakeholders, of the feedback that is gathered. And ideally also before the filing, that there's an opportunity for sharing how that feedback was incorporated into proposals for the coming year.
Well, we'll certainly be making this recording available. I think we talked about that earlier. We'll be posting it on our website and we'll be sending out a link to that. We'll also be submitting our slides as a filing into the 2019 hosting capacity analysis docket on eDockets. And we'll include a link to that filing as well in the email that we send out to everyone following this, this workshop. And like I said, we'll plan on talking about how we've considered and incorporated the feedback from these sessions into our 2020 analysis in our filing. Does anybody have any other questions or comments, observations you want to share? All right, with that, I think that is going to conclude our workshop today. Thank you very much for joining us. Thank you for your questions and helping to make this interactive for everyone. I think that always helps reinforce what's being said and just helps everybody understand better. So we really appreciate the dialogue. Oh, I did get one question here that just came in back to slide 6 of the first presentation. I don't know if we can get that pulled up.
I've received that as well, and I believe I can answer that, not necessarily with the slide. The question is, could we discuss the summary of the budget creation process within the distribution planning timeline and how it feeds into the hosting capacity process? So in short, they're fairly exclusive. The budget creation process is based entirely around planning risk assessment, looking at, again, areas of potential load growth, where capacity projects need to be created. Those projects are planned out with, on a high level budget system. They're scored based on their cost as well as the amount of risks that they are mitigating, and then move forward into our full annual budget. Hosting capacity does not interact with that. With slide 6, the key point that I was trying to make was that because hosting capacity analysis is performed by distribution planning, there are kind of two buckets that are being juggled simultaneously, and that's just kind of where they align with each other. The main portion of the planning process that is required for hosting capacity is that load forecasting.
I guess this is Mary Santori from Xcel. The one thing I would add is that as we do put projects into our budget and then we move towards getting those accomplished, those are pulled into the hosting capacity.
That is correct. Thank you, Mary. Yes, we look forward at our projects that are being planned in the coming year, and hope to have an in-service date within the coming year before starting hosting capacity, and choose those projects choose the feeders with those projects to be remodeled rather than reusing old models.
Okay. Hopefully that answers your question, Ryan. If not, if you can unmute and ask it a different way, or supplement it, or ask folks to clarify. looks like it's good enough to go. All right. Well, with that, I think we're done for today. We're really looking forward to seeing you all for our second workshop on June 16th to take a deeper dive into our analysis, and want to thank you again for your participation and the dialogue and engagement with everyone, and stay well these days. Thank you.
Thank you all.
Thanks so much for your time today. Really appreciate it.